We're going to start our unit today on circles. So this is section 9.1 to 9.3. The objective is students will review the basic definitions and properties of circles. So first of all, we're going to talk about some vocabulary here. The first one is circle. The definition is the set of points on a plane that are equidistant from a fixed point. The fixed point is called the center. So we're going to put a little point here in the middle. This will be our center. So all of these points on this line are all the same distance away from the center. A chord is a line segment whose endpoints both lie on the circle. So I do two chords here. Chord AB, so A is an endpoint on the circle and B is an endpoint on the circle. And then the line that connects them together. So this would be a chord. CD would also be a chord. Both endpoints are on the circle and the line that connects them. Okay, diameter. Now notice diameter says a chord, so it is a chord, but it's a special chord. It passes through the center of the circle. So this chord, the endpoints are both on the circle, but it passes through the center. That's the diameter. Radius is a segment that has the center as one endpoint, so right here, and a point on the circle as the other endpoint. This would be the radius. Secant is a line that intersects the circle in two places. So I have a line that goes through it, and it intersects the circle in two places. A tangent, these words I know sound familiar, even though you don't know yet why we use them with trig and what that has to do with circles, but later on in math you will. But we call this one the tangent. And it is a line that intersects the circle only once. The only way we can make that happen is for it to just brush against the circle right there. So then we have the point of tangent C. That is going to be the point where it actually touches the circle right there in one spot. So this would be the point of tangent C. We can label it as a P for the notes here. A central angle is an angle with its vertex at the center of the circle. So I drew one. This is an angle. Here the vertex is the center, so A would represent the center of the circle. And when we draw the central angle, it intercepts this arc right here. BC is known as an arc, and we write it like this, an arc. So BC with this little half circle over it would be an arc. An arc formed by a central angle is equal to the angle. So if angle A happened to be 30 degrees, then arc BC we would say would be also 30 degrees. Okay, an inscribed angle. Now I want you to look at the picture of both of these and see what's different. And if you notice, it's going to be the location of the vertex. A is the vertex. It's where the two lines come together to form an angle. And it's in the center of the circle. But an inscribed angle, it's on the circle. So the vertex of the inscribed angle is actually on the circle, right here. An arc formed by an inscribed angle is twice the measure of the arc. So let's say in this case, let's say angle A is 30 degrees. In this case, then BC, arc BC right here, this is the arc formed, it's cut out, would be twice that size. So it would be 60 degrees. Okay, so if the angle is central, then the angle measure is the same as the arc. If the angle is inscribed, then the angle measure is going to be half the measure of the arc. Or we can also say the angle measure would be, the arc would be twice the size of the angle measure. A major arc is an arc measure that is always greater than 180 degrees. So usually when we write a major arc, we'd have another point maybe here, and we're going to label it with 3 points. We'd say BDC would be a major arc around the circle. So I'm going to rewrite this and say BDC would be a major arc. So let's say the angle A was 30 in this one. Then arc BDC, well, how many degrees are in a circle if we think back? And we can remember that it's 360. So BDC would be 330. And that would be a major arc. You're always going to know it's a major arc if it's greater than 180 degrees, because 180 is half of a circle. It's a straight line also, if we remember. So if we had a straight line across here, that would make half of a circle. Okay, rest of the vocabulary. This is a lot of vocabulary. A minor arc. Its measure is always going to be less than 180 degrees. So if we look over here, BC would be a minor arc. And just as the central angle was the same back when we did the vocabulary about central angle, if angle A was 30 degrees, then the minor arc would also be 30 degrees. This is the central angle. So it says here, the measure of a minor arc is the measure of its central angle. Half of a circle is 180 degrees. So I was talking about a minute ago, it's a straight line. We know that a straight line has 180 degrees. So that would make sense that half of a circle would also be 180 degrees. And we call that a semicircle. Okay, now we have two theorems here that help us to determine the measure. One is to help us determine the measure of this angle, the central one, or not central, but this interior angle. And this other theorem helps us find the measure of the exterior angle down here. So let's read the definition, and as we read it, I'll show you the parts that go along with it. If an angle is formed by two intersecting chords, so here's my chord AD, and it intersects chord CB. So I have two intersecting chords. Or secants, which just means secant just means this could be a line that continues through the circle, such that the vertex of the angle is in the interior. Now notice, this is the vertex. It's where the two lines come together, and it's inside the circle. That's what this means. The angle is in the interior of the circle. Then the measure of the angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So what that means is that these two lines intercept two arcs, and it's this arc right here and this arc. Okay, if I were to add the measure of AB plus the measure of CD and then divide it by 2, that would tell me this angle right here. Now if we notice, we know from geometry that this is a vertical angle, so it would also tell me the measure of that angle. And then I can find the measure of these two angles right here as well, because they would make a linear pair. So I can know all four angles with that theorem. Okay, the exterior angles of a circle theorem says that if an angle is formed by two intersecting chords, so I had two intersecting chords again, or secants of a circle, such that the vertex of the angle is on the exterior. So that's saying here's the vertex of the angle. It's outside the circle. So the angle is, the vertex is exterior. Then the measure of the angle is half of the difference. This one was half of the sum. This one was half of the difference. So the only difference between these two theorems right here is that this one is addition and this one is subtraction. So, maybe you can think of it as a negative thing to be outside the circle of friends. You're outside your circle of friends, so that'll help you remember to subtract. When you're inside your circle of friends, it's a positive thing, so you can think of that as positive. Think of your own way to help you remember these two theorems. So I would take angle AB, or arc AB, and arc CD, and once again, I would take AB minus CD. You're going to take the biggest one, subtract the smallest one, and divide it by 2. And that will give me the measure of this angle and this angle. Okay, let's try some of this. So if we go down here to this example, label each part of the circle. So the first thing says center of the circle. If we look at our circle here, the center is the point in the middle, and so that would be A. So it would be point A. B says all radii of the circle. So that's the radius. So we know that a radii has to originate from the center of the circle. So AE would be a radii. So we can say AE. AB would be a radii. And then I could say AC would be a radii. And that's all, or a radius I should probably say. That's all there is because A is the center and there's only 3 lines that originate out of A. Okay, the diameter, there can only be one diameter here because it goes through the center of the circle, and there's only one line that goes through the center of the circle. I could have a diameter here as well, but according to this circle right here, there's only one diameter listed. So I know because it goes through the middle. So BC would be a diameter. Okay, a secant line is a line that intersects the circle in 2 places. So I'm looking for a line that continues through the circle and intersects it in 2 places. And that would be line DE. And we would write it like this. Okay, a tangent line. Sorry, my thing's freezing a little bit. DE. Doesn't look very clear. Tangent line only intersects the circle in 1 point. So if I look here, FG intersects the circle in 1 point at C. So it would be FG. Now, it doesn't ask us to find the point of tangency, but if it did, it would be point C right there. All chords. So a chord is where its endpoints are 2 points on the line. So I could say D and C would be a chord. I would say that B and C is a chord. That was also the diameter, if you remember. And from the definition, a diameter is a chord. So 2 endpoints on the circle. Do you see any others? Let's see. D and E. It is part of the secant line, but this section right here, D to E, would be a chord. So we call it DE is the chord. And then all central angles. So if it's a central angle, it has to originate from angle A. So CAB would be a central angle. Even though it's 180 degrees, 180 degrees is an angle measure. BAE would be a central angle. CAE would be a central angle. And I think any others that we have, like we could have CAB again this way, but they're all combinations of this, so we'll leave it at that. All inscribed angles. So this means the vertex has to be on the circle. So if we look around the circle, let's just go around it and find a point on it and see if it has a vertex. So D is a point on the circle, and it is a vertex right here. So an inscribed angle would be CDE. And then let's go around and we find C here. Another inscribed angle would be DCB. And then we would keep going around the circle. E, we could have, now this doesn't continue on through here, so we're not going to call this one an inscribed angle. We could draw a line there and have it continue, and that would be an inscribed angle, but it doesn't finish all the way through, so we're not going to count that. And then B only has one line that intersects with that point, so it's not, there's no inscribed angles there. 2 major arcs. I already wrote these beforehand, but if we look, we have B, C, E. That's this whole arc right here. That would be a major arc. DCB would be DCB right here. That would be that major arc. And 2 minor arcs. DB would be a minor arc, and BE would be a minor arc. Okay, determine the measure of each minor arc, AB. So if we remember the central angle theorem, this is the center of the circle. So if this angle is 90, then arc AB we write it like this, arc AB would also be 90 degrees. Okay, GH is this arc, and this is the center of my circle. So if GH is 135, or GOH is 135, then the arc GH would also be 135 degrees. Okay, number 3, determine the measure of each central angle. Okay, so now I'm given the arc and I need to find the central angle. This is probably the easiest one. So I have 30 plus 50, so that would give me 80. So angle XYZ would be 80 degrees. This one says VIQ, and it's a straight line here. So it should tell me automatically it's 180, but if we look at this arc too, and we have 95 plus 85, I think there's supposed to be a line right here, probably on this one too. Then I'd have 95 plus 85, so angle VIQ would be 180 degrees. Determine the measure of each inscribed angle. So this arc right here is 150. So if we think about our theorem, then this angle, XYZ, is going to be half the measure of 150. So it would be 75 degrees. This one says KLS. It's an inscribed angle because the vertex is on the circle. So if this is 112, the arc that it intercepts right here is 112, then the angle over here is going to be half of that. It's going to be 56 degrees. On 5, determine the measure of each intercepted arc. So this one tells me that this is 54, so the angle of the inscribed angle here is 54, so the arc is going to be twice that, which would be 108 degrees. DS is, if angle DPS is 90, then arc DS is going to be half that, or twice that, excuse me, so it's going to be 180 degrees. And that makes sense because if we were to connect those, I'll try to freehand it here, be a diameter of the circle. So this angle, this arc measure would be 180 degrees. Now DB is a diameter of circle P. So DB is a diameter. And we're going to use that information plus what is given on here, that this is 90 and that's 35, to answer these questions. So DPC, this angle right here, says what is the measure of that angle? If we look here, 35 plus that angle, they lie on a straight line, so they are a linear pair. So to find the measure of that angle, I would take 180 minus 35, and I get 145. CPA would be this angle from here to here. So I would just take 35 and add 90 to it, and I get 125 degrees. Okay, arc CDA, that's this arc measure. I'm going to look at the measures of the interior angles, the central angles here. This one was 145. If this is 90, and they're both on a straight line, then this has to be 90. So if I want to find this whole arc, I need to take 145 plus 90. And I get 235. Arc BC, that's this one. If my central angle is 35, then my arc is going to also be 35. And then arc DA, right here, if my central angle is 90, then my arc is also 90. Let this catch up. There we go. All right, last page. Given that, hopefully this catches up. There we go. Given that angle SPR equals 35 and PQ equals 84, find SR. So I'm looking for this first. Now look, I don't want to draw all over this so that I can see it for my next one, but here is an inscribed angle. Remember the definition of inscribed meant that the vertex was on the circle. So P is the vertex and it's on the circle. That means that the intercepted arc across the way is going to be double that. So if that's 35, then this would be 70. PRQ is this one. And this one tells me that the intercepted arc here, PQ, is 84. So the angle that's opposite over here is going to be half of that, which would be 42 degrees. Okay, measure of angle ACB. That would be this one. It wants me to find this one. So my intercepted arc, if I go straight across the circle, is AB, and it tells me that that's 80 degrees. So ACB is going to be half of that, which would be 40 degrees. Arc DC is this one. The angle that's opposite it is 60. So the intercepted arc is double, so that would be 120. Last part says AD. Now at first this might look a little bit hard to figure that out, but we're going to use some information that we know. If I were to connect this line right here, this would make a central angle at R. And if this arc is 80, then right here this side would be 80. If I were to connect that line, if I know that this is 80, then let's see, these are not a vertical line. Sorry, I need to write that out. I'll pause it while I write that out. Okay, so this one, this side I already said was 120, so that meant my central angle here was 60. Sorry, 120, I'm messing up all over the place. Because it's the same. So the central angle is the same as the intercepted arc. The reason why I got 120, if you look over here, DC was 120, because the inscribed angle right here was 60. So if I came straight across the circle, I double it. I got 120. So my central angle is 120. Now this is a linear pair right here. So it'd be 180 minus 120, so this would be 60. This is a linear pair right here, so this would be 100. It kind of looks like it is, like maybe those were vertical angles, but if we look here, this line, if it kept going straight, it would go something like this. So that's why this and this are not vertical angles, because this takes a slightly different angle here as it comes across. Okay, so if this angle is 60, then this arc here would be 60. And if this angle is 100, then this arc right here would be 100. Determine RS if UV is 30 and RTS is 80. So angle RTS is 80 and UV is 30. Now this was that theorem that we called the interior angles of a circle theorem, which said if I take 1/2, this would be arc RS plus arc UV, that would give me this number. So it'd be RTS in this case. So let's fill in what we know. We have 1/2. We don't know RS. That's what I'm trying to find. Determine RS. So I'm just going to put RS plus UV, it tells me, is 30. And that equals 80. Because angle RTS is 80. So first thing I'm going to do is get rid of this fraction. So I'm going to multiply both sides by 2. So that would leave me RS on this side plus 30 equals 160. I don't really need parentheses here anymore, so I can drop the parentheses, and that means I can just subtract 30 from both sides. So RS is 130 degrees. It doesn't look like it is, but that would be the measure of this arc right here, 130 degrees. So probably some of our numbers look a little bit odd here to make the picture look real, but we sometimes with math just have to go with what the problem says. Okay, last problem. Determine the measure of angle D. So this one was, so I'm looking for this angle right here. This was my exterior angles of a circle theorem. So if you go back to your vocabulary, that's when I took 1/2 this arc plus this arc, or subtract, excuse me, it was the difference. So I'd have 1/2 ZB plus CB. Oh, I keep saying plus and I meant to say subtract. Just go like this quickly, wipe that out. Let's subtract. And that would equal angle D. So let's figure out what we have, and we can solve this problem. Remember that to subtract there. Now I've got white out everywhere. All right, so 1/2 ZB, it tells me that ZXC is 150. Okay, so this whole length is 150. So what would ZBC be? That would be 360 minus 150. Let's figure out what that is. 360 minus 150, and we get 210. So if I were to go to Z all the way to C, that would be 210. Okay, but I know that CB is 30. So from here to here is 210. Then from here to here is going to be 210 minus 30. So that's going to give me 180. So I'd have 1/2 180 minus 30 would give me angle D. It's going to be 1/2 of 150. Gives me angle D, which is 75. Okay, the assignment that goes with these notes is at the bottom of here. It's 9.1 to 9.3 worksheet in your yellow book.